what did I just say, number 6? All right. I really like number 6. Please make sure you understand it. Hint, 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 hint. All right. So number 6 is meant to be like, so in the video for 7.5, there was like a video within the video, right? And it was the mountain from the Game of Thrones show throwing the big keg over the, I don't remember if it's a wall or a net or whatever, but he's throwing this big thing, right? Okay, that's what number 6 was meant to be. It says, suppose Brutus is now trying to throw the barbell in the previous problem straight up into the air. He exerts 4,000 newtons straight up and releases the bar at the instant he has raised it 2.35 meters. All right, so you need to identify important points in the object's motion. How you make your drawing is kind of up to you. But so the way I'm picturing it is this. Here's the barbell on the ground. Okay. Let me do this. I'm going to make 2 separate drawings. So what am I doing? Right, so here's Brutus. Need to calibrate my board. All right. So that's the first drawing, right? So in that drawing, the height of the barbell is 0, the velocity of the barbell is 0, right? Okay, then he goes, hi-ya, and releases it here. And the problem tells us that he releases it when it's at a height of 2.35 meters. But notice, I don't know the velocity at that point, do I? Make sense? All right. Then it's now moving up. He's released it, and so there's going to be some other point over here where that's him pointing at his victory. And here's the barbell up at the top of his path. Okay? All right. So what do we know up here, you guys? At the top point. The velocity is 0, but we don't know the height. Follow? So notice I've begun. Why am I dumb? I've started by identifying the important points in the motion of the barbell. Good? All right, now I'm going to simplify this. Let's call this point A, point B, point C. So let's just make one drawing. So here's the barbell. It's going to go up. It's going to come down. So here's point A on the ground. Here's point B where he releases it. Here's point C at the top of the path. Follow? All right. So at point A, I know my height is 0 and I know my velocity is 0. At point B, I know my height is 2.35. I do not know the velocity. At point C, I don't know my height, but I know my velocity is 0. So that's just sort of like a condensed drawing without crappy stick figures. Make sense? All right. Are there any questions before I go on? Okay. Now, there's a couple other pieces of information that I have not yet written down. Those are as follows. The problem tells us that the mass of the barbell is a ridiculous 240 kilograms, which is like 500 pounds. It also tells us how much force Brutus exerts, right? Force of Brutus is, what is it? Is it 1,200 newtons? I don't think I did it wrong. 4,000 newtons, okay. He's very, very strong. 4,000 newtons. Good? All right, so I've written down everything I know. Everybody good up to there? All right, so next thing, continue on autopilot. Figure out anywhere you know the height, find the GPE. Anywhere you know the velocity, find the KE. Okay? So let's see, down here at point A, I know my GPE is 0. I know my KE is 0. That means my TE is 0. So that's all point A. Everybody good? All right, up here at point B, let's see. I know the height, so I can find my GPE. gives you 5,000 something or other. 5527. Cool? Everybody good or no? Yeah. All right. I don't know my velocity, so I can't find my kinetic energy. That means I don't know my total energy. Follow? All right. And at the top of the path, I don't know my height, so I don't know my GPE. My velocity is 0, so I know my kinetic energy is 0, but I can't find my total. All right. That's it. Autopilot. Done. Let me pause for a minute. Are there any problems with what I've done so far? I cannot emphasize enough the importance of this. Identify these important points and think about your energy at each point. If you haven't done that, you're not doing the problem. Follow? All right, so now we got to solve this thing. So there are two questions. The first part wants to know the velocity here when he lets go of it. The next part wants to know the height here at point C. But we're kind of stuck, right? So once you get to this point, once you get stuck sort of at the end of your autopilot portion, your question should be, what do I know about my total energy? And again, same two answers as before. It either stays the same or it changes. Okay? So, but you got to be careful because it sort of depends on the time interval. So, from here to here, I'm unhappy with how I set this up. Between points A and B, is the total energy constant or changing? Changing. Good. How do I know it has to be changing? Okay, 1, because the total energy here is 0, and it's clearly not going to be 0 here, right? Secondly, why? Why did the total energy change between here and here? Because we've got a non-conservative force from Bruno, or Brutus, or whatever the hell his name was. Right? Oh, so there's a change in total energy here caused by the work done by our non-conservative forces. What's our non-conservative force? Brutus. Ah, I feel like I should figure out what that change in total energy is. Follow? So, there's two ways you can find the total energy. Sorry, try that again. There are two ways you can find the change in total energy. You can subtract. That doesn't help us any, right? I don't know the top one. Or, work done by Brutus is, well, it's force times displacement times cosine of the angle. But I'm not worried about the angle because both the force and the displacement are up. Clear? All right, so how much force does Brutus exert? 4,000 newtons. Now, this always messes people up. Through what displacement? How far does it move between points A and B? 2.35 meters. It's okay for your displacement and your height to be the same. Last year, I remember a bunch of people were like, I thought that 2.35 meters was the height. Yeah, it's also the displacement. It's how far it moves between him picking it up and releasing it. Okay? So multiply this out and you get 90, whoa. You get 9,400 joules. Good? All right, cool. So why does that help me? What does that mean? That's the work Brutus did. Great, so what? What does it mean? That's our change in total energy, right? How much energy did it have before Brutus touched it? 0. And then he gave it 9,400 joules, so what's the total energy in drawing B? Well, 0 plus what we gained, so you're going to just have 9,400 joules, right? Clear? Okay. So now, now I know my GPE and my TE, so now I can subtract to find my KE. Make sense? So let's grab the calculatrix. 9,400 minus 5,527. So the kinetic energy is 9,400 minus 5,527. Kinetic energy is 3873 joules. And so now I can find the velocity. So the kinetic energy is 3873. That's got to equal half of the mass times v squared, and solve it. And your velocity turns out to be a number that I don't know, but I have a calculator, and it's 5.7 meters a second. A lot going on there. Does that process make sense, you guys? Questions with it? All right, so that was the first question. What's the velocity when he lets go of it? Is everybody good there? Okay. To be clear, the reason that our total energy at points A and B are different is because Brutus did work. Clear? All right. Now, any questions before I go on? All right, because something important happens for part C, so I want to make sure everybody follows along for part C. Everybody good? Okay, now, the next part wants to know what's the height at point C. And again, we don't know our total energy, right? Now, between A and B, the total energy changed because there was a non-conservative force of Brutus. What important thing happens at point B? Brutus lets go. So between B and C, between here and here, what do we know about our total energy? Is it constant or changing? It's constant, right? Because after he lets go of it, the only force on it from here to there is gravity, right? So the total energy doesn't change. So what's the total energy up here, you guys? Same thing it was there. Does that make sense, you guys? Oh, and if the KE is 0, then the GPE must be 9,400, and we can find our height. Excuse me. Does that make sense, you guys? Whoa! Does that make sense? I almost spilled my coffee. That's why I just said whoa. That had nothing to do with the problem.
Yeah.
Yeah, hi.
Can you explain why the total energy is 9,400? Sorry, I missed that.
No, that's okay. That's okay. Are you okay with why the total energy at B was 9,400?
Yes.
Because Brutus did work, right? So between, and the drawings or the board's about to get really cluttered, and I apologize. So between,
He's not like doing networking work. He's letting go. So like, why is this not the same?
it's so yeah. I mean, so the idea is, so before he touched it, the total energy was 0, right? While he does work, what's happening is he's giving it more and more and more energy. So he gives it more and more and more and more energy. So by the time it gets to here, now the dumbbell has 9,400 joules of energy. Okay? When he lets go of it, he's not doing anything to take that energy back. The dumbbell, he's already given the dumbbell that energy. It still has that energy. Follow?
Yeah.
So while it's in the air, he's not doing any work on it anymore, and so the total energy doesn't change. It just stays the same. Okay, what's the only force acting on it while it's in the air, you guys, and Maya specifically? While it's in the air, what's the only force on it? Gravity, right? But remember, gravity is conservative, and it doesn't change your total. Did that answer your question or no?
Yeah.
You're good?
Yeah.
Is everybody good? Thank you for asking. Everybody's happy? Okay, cool. So, I guess we might as well finish it, right? We're 99% of the way done, so let's finish our one last part. So then to find the height at point C, So at point C, we know that our GPE has got to be 9,400 joules. And so then you just do GPE is MGH. So 9,400 equals the mass of the dumbbell times 9.8 times 8. Solve for your height. And it gives you a big number, 2 point, no, 3 points. I have no idea what the answer is. Anybody know what it is? 4? 4. Thank you. Thanks, Max. Cool, you guys? All right. So in third hour, I went over number 7, and I like number 7. And I've already been talking for like 40-something minutes. So I'm going to give you guys 2 choices. Choice 1, or I guess 3 choices. And probably the third choice will be the best option.